Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed rearrangement of an allylic propargylic alcohol, semipinacol type rearrangement, combined with ring expansion. Step 1. Identify the starting material. The starting material is a spiro compound consisting of a cyclobutane ring and a 2,3-dihydron ring sharing one carbon, the spiro center. The cyclobutane carbon at the spiro center also bears a hydroxyl group, tertiary alcohol. The dihydron has AC is equal to C double bond adjacent to the oxygen. Step 2. Protonation and carbocation formation. Under acidic conditions, H+, the hydroxyl group is protonated and water leaves, generating a tertiary carbocation at the spirocarbon, the carbon shared between the cyclobutane and the dihydron. This carbocation is also allylic because the dihydron double bond is adjacent, providing resonance stabilization. Step 3. Semipinacol ring expansion rearrangement. The cyclobutane ring, which is strained and attached to the carbocation center, undergoes a 1,2 carbon shift ring expansion. 1C. C bond of the cyclobutane migrates to the adjacent carbocation center, opening the 4-membered ring and forming a 5-membered ring, cyclopentane. This ring expansion relieves cyclobutane ring strain and is strongly favored. Step 4. Formation of the product. After the 1,2 shift, the resulting carbocation is stabilized and quenched. The oxygen of the dihydron ring remains incorporated in the product. The net result is a 1-oxaspiro, 4.4, nonane skeleton with a ketone. The positive charge is quenched by the adjacent oxygen lone pairs, forming an oxocarbenium which loses a proton to give a carbonyl. The product is a spiro-bicyclic compound with one 5-membered ring containing oxygen, tetrahydrofuran derived, and one 5-membered carbocyclic ring bearing a ketone matching option, a spiro, 4.4, nonane framework with an oxygen in one ring and a ketone, oxaspiro-bicyclic ketone. Step 5. Why other options fail? Option B retains O and the original ring skeleton. No rearrangement occurred, not the major product under H+ with a strained cyclobutane present. Option C shows the spiro-bicyclic ether, no carbonyl, which would require the oxygen to simply close without oxidation state change at carbon, does not account for the full driving force of ring expansion plus carbonyl formation. Option D places the ketone outside the THF ring in a different connectivity inconsistent with the migration pathway described. Therefore, the correct answer is A. Therefore, the correct answer is option A.